You are welcome to this lesson. We are still talking about the application of differential calculus, and this is a tutorial question 2020-2021. We are now at question 28. This question 28 is talking about the application of differential calculus in approximation. Now, the question reads, if a side of a square increases by 0.5%, then we asked to find the approximate percentage increase in the area. So basically here we are talking about the percentage increase in area of a square. Now, what is approximate value? How do we get this approximate value? We can get the approximate value by taking this. Bear in mind that delta y to delta x is roughly approximate to the y dx. Okay. Now, the reason why it is roughly approximate is because we did not take the limiting value as delta x tends to 0. So delta y to delta x is roughly approximate to the y dx. So which means if I'm looking for the change in y, I have to cross multiply delta x to this side, and that will give me delta y to be roughly approximate to the y dx delta x. So this is the approximate value we are going to be using for this problem today. Now, how do we go about solving the problem at hand? First, you need to know that we are dealing with a square, and I'll quickly draw a rough sketch of the square here to give us a visual view of what I'm talking about. So we know that all the sides of a square are equal, all right, and the space bounded by the straight lines, that is this part here, is the area, which has a formula for what? X squared. So we can say that a equals to what? X squared. Now, the first thing is for us to differentiate this, okay, which will give us dA dx. And what is our dA dx? Is going to give us 2 times x, which is 2x, then 2 minus 1 is 1, so we have 2x power 1 here. Now, going further, we know that we already have this dA dx to be equals to 2x. But if we come back to this approximation, our dy here, the y is being replaced by a. So I can say that delta a to delta x will approximately equals to what? dA dx. So we are going to cross multiply this to this part here. Okay, that will give us delta a to approximately equals to what? dA dx delta x. Now we know that we just gotten the value for dA dx as what? 2x. So which means that our delta a will approximately equals to what? 2x delta x. All right. Now, in the next thing we are going to do is this. We are going to compare, we are going to write this change in area as a ratio of the original area. So which means that we can say that delta a to a, all right, will approximately equals to 2x delta x, then divide by what? X squared. Don't forget that a is equals to x squared, as you can see from where we started, okay? Now, what does this mean? It means that on this side we have delta a to a, and that will approximately equals to what? One of these x will cancel one of the x here, and you'll be left with 2 delta x to what? To x. Now, this tells you, since we are dealing with percentage increase, before there is an increment, the original area here is 100. And before there is an increment, the original side or length is also 100. So we're going to write that out, our delta a to 100, and that will approximately equals to 2 delta x to what? 100. And if we do this division, you see that our 100 here will cancel this 100. You'll be left with what? Delta a to approximately equals to what? 2 delta x. Now, if we go to that question, you will see that we are told that the side of the square is increasing by what? 0.5%. What does that mean? It means that our delta x, which is the change in the side is what? 0.5%. Now we are going to bring this value we've gotten here, which is delta A, to roughly approximate to 2 delta x. We are going to bring it out here and write, therefore, our delta A is approximately equals to 2 delta x, and that will give us 2 multiplied by 0.5. And if we do that multiplication, we are going to have the change in the area to be what? 1.0%. And this is the final answer to this question.